Good morning, Algebra 2 students. Here's a little help with the 6.5 practice on factoring techniques. So for number 1, the first step is always take out the greatest common factor. So what is common to both terms here is 5 and an A and a B. And then if you divide each term by 5AB, you'd be left with 3A minus 2B. And that would be as far as you can go with that one, as far as factoring goes. Number 3, taking out what's common. It looks like each term has an X common at least, and a Y. So I'm going to take out an XY. That's going to leave me with 3XY minus 2X plus 5. And then once again, there's nothing more you can do because it's not of any second degree. It's not a trinomial of any type. So that's the only step there. Number 5 has 4 terms. So this would be grouping. We would group these first 2 terms together. I could take a 7 out of that, which would leave me with 3 minus t. And then these next 2 terms, I could take out an r, which would leave me with 3 minus t. And then 3 minus t, you can see, is common to both of these terms. So I'm going to take a 3 minus t out of each of those, which leaves me with 7 plus r. And that has been factored by grouping. Number 7, there is no greatest common factor. It's not one of the special ones. So you can see 96 is not a perfect square. So this would be done by trial and error. I'm going to make my 2 sets of parentheses. My first terms have to give me y squared, so I need y and y. My last terms have to give me a product of 96. So going through those factors. I believe 4 goes in there about 24 times. 1 and 96, 2 and 48. 8 goes in there, I believe, exactly 12 times. That seems to me like it will give me 20. Both signs have got to be positive. And if I check this, I have 8y and 12y, which does give me 20y. And so that does work. And that is factored. That's a trial and error one. Number 9, same type. Looking through this, no greatest common factor. It doesn't involve any squares or cubes. So I'm going to do this by trial and error. 6n squared, my first terms. Could potentially have 3n and 2n. Potentially could have 6n and 1n. My last terms factors of 2, 1 and 2. I'm looking at this second one here. If I put a 2 there, that gives me 12n. And the 1 here, that gives me 1n. That's going to work if the 12n is negative and the 1n is positive. Number 11, there's no perfect squares involved. There's no greatest common factor. This is going to be trial and error. And I believe if you go with x and x and you need factors of 8, which could be 2 and 4, could be 1 and 8, but I don't believe there's any way you would get your outsides and insides to give you a negative 8x. This one's not factorable. So we say this is prime or not factorable. Number 19. Now these are asking you to solve the equation. So we're going to want to factor this as completely as we can. I can take a y squared out of everything. And then keeping that y squared. Looking on the inside, I believe this is trial and error because there's no perfect squares or cubes involved. So I got y and y. I'm going to use 9 and 2. I would need a -9, +2, so that I get that middle term of -7y. Now when we're solving this, we have to go one step further and ask ourselves, what makes each of these factors equal 0? What makes y squared equal 0 when y is 0? What makes y minus 9 equal 0? +9. And y plus 2 would be -2. And those would be your three solutions there. Number 21, this potentially looks like it could be difference of squares. I think 25 times 25 is 625. So difference of squares, I would have m squared and m squared. I'd have -25 and +25. And then this first factor, m squared minus 25, is also a difference of squares. So that would be m minus 5 and m plus 5. And sum of squares, we cannot factor. So this is factored as completely as we can. And now my solutions would be +5, -5, and m squared plus 25. We're going to have to set this equal to 0 because that doesn't factor. If I subtract 25, take the square root, I have the positive and negative square root of a -25, which hopefully you remember is 5i. So this one has two real solutions and then has two non-real solutions. '23 could potentially be a perfect square trinomial, but I don't think 7 and 7 is going to give you 50 in any way. So I believe this is also trial and error. So I've got x squared and x squared. Both my signs have to be negative. And I believe if we have 1 and 49 in here, it would work. It gives you -50. But this is difference of squares, x minus 1 and x plus 1. And this is difference of squares, so x plus 7 and x minus 7. And then your solutions would be, what makes each of these 0? +1, -1, -7, and +7. So I hope this helps you in completing the 6.5 practice on factoring techniques. You might be wondering, I don't see any difference of cubes or sum of cubes in this particular assignment.
Good morning.
Is that Abigail?
Yeah.
Oops, sorry.